Hola, buenos dias. My name is Zheng Li. I'm from University of Concepcion in Chile. We have only 10 minutes, right? So I will try to explain our research story clearly instead of going too much deep into the technical details. Given the whole ecosystem, given the popular technology stack for implementing microservices, a very natural idea is we can containerize the database to implement individual microservices, right? But there are different voices. There are kind of fierce debates in the open source community. We don't have to look at the academic publication. We can just search online in the open source community. We will hear different voices. The stronger voices is that, yes, we can use database containers, but only in the development and testing environments. We should never use database container in the production environment. Why? Because the database containers could make us a lot of trouble in production. So the very popular solution in practice in industry is that since this is too complicated for software engineers to handle, let's just outsource the troublemaker, this troublemaker to others. All right. In this case, let's outsource this troublemaker to the public cloud, because we already have very well managed public cloud database service to use. Then we just employ those cloud database service. In this case, we don't have to worry about building up database containers in production. We still containerize the other components, functional components, the other microservice components into containers, right? But leave the database part to the public cloud service. So this is the current popular solution in practice, and it works very well. And this seems to be the most popular recommendation in industry. Fine, we couldn't agree more with this, but we met some troubles in our work, in our kind of project. For some reason, we don't have available cloud database service to use because we are working in a private cloud. We are working in a relatively poor private cloud. This is a long and interesting story. I can explain more offline if you are interested. But anyway, we don't have available cloud database solution to use, and it's too much work for us to develop those sophisticated solution to use either as well, because we don't have enough cloud engineers, we don't have enough infrastructure engineers, we don't have enough database engineers to collaborate with. So we tried to bypass this issue. We tried to develop a lightweight solution to satisfy our own requirement only. Then we developed this. It's like a read-only database container scenario. In this case, we just dump the whole master database into a long script file, all right, just like SQL scripts. And then together with some necessary data, we can preload the database together with the data into a, when building the database image, when building the container image offline. And then when we deploy and running the database images into containers, the alive database containers will have the database together with the data in production environment. And we constrain that this scenario is only for read only from the user's perspective. Okay, in our case, it's like that microservice is like API catalog or product catalog. All right, so all the catalog is designed and implemented by engineers. The users will not modify the catalog at all. They don't need to modify, and they are not allowed to modify the product catalog, right? API catalog. They just need to select suitable ones to use or explore. right? So this is a very typical read-only scenario. And we can use this way, we can use this solution to satisfy our read-only scenario requirement. In this case, we don't have to worry about these uncertain issues. For example, if we use external volumes, we will meet frequent dangling volume issues. And this is just one case. There are many, many other tricky issues in production, in long-running container database situations. So it's not worth it. But in this case, if the one database container vanishes, suddenly disappeared, doesn't matter, the coordination tool like Kubernetes will launch a new one. And all the data will be there because it's not modified, it's read-only data, pre-baked into the image, now in every single database containers. And because they are read-only, there's no update inside among the cluster of the database containers. We don't have to worry about the synchronizing data requirement of synchronizing data, right? We can avoid many tricky issues. And based on this scenario, we also proposed some other possible scenarios that can be suitable to apply our solution. It's like this, the eventual consistency scenario. We can imagine the recommender system to understand this scenario. For example, when we shop online, okay, on Amazon's online shopping platform, we can always receive recommendations about other products, other books, when we buy some stuff, right? So in this case, of course, our online shopping activities will also be reflected in the future recommendations, but not for now. It's impossible to immediately reflect our current online shopping activities in the recommendations, but that's fine. The users, we don't have to worry about that. There's not a big loss in the, it's not a big loss in business value at all, and we don't worry about that. Okay, there's no 100% accurate recommendation at all. So the users will not be even aware of this. So this is the eventual consistency scenario. And very similarly, there could be asynchronous processing scenario. We can imagine this scenario through our let's say flight ticket booking experience. I know it should be a long time ago, right? Let's imagine what do we the online shopping process when we book flight ticket through Expedia. All right. After we finish our payment, we will receive messages like, well, your booking is done, but please come back and double check your e-ticket numbers in another couple of days, in a few days. Because we know we can't immediately get the e-ticket numbers, right? It'll require more time to process, to finalize issuing the e-tickets. The users will know this, the users will understand the delay, and the users will be okay with such a delay. So in this case, in this asynchronous processing scenario, we can increase the delay a little bit by rebuilding database images, by integrating the updates, the e-ticket number in this case, into a new database image. And then we deploy the new database image and run the new database image into the database containers, okay, to replace the old ones. We already have the mature techniques to do so, offered by the third-party coordination tools, right? So it's not a big deal, it's possible. But the users will not know and will be tolerant with the slightly increased delay, okay? So it should be suitable. It should be a suitable scenario to apply our solution. Anyway, long story short, we believe this container native database persistence can be viewed as a conditional solution. I believe time is already up. So muchas gracias.